Good afternoon, ladies and gentlemen. My name is Beliautsou Viktar, and now I'm going to present you a project of my team. We are working on developing a stabilizing system for unmanned aerial vehicles with variable thrust vector. Nowadays, aviation has high reliability requirements. All new ideas, solutions, and technologies which want to be embedded into the planes should pass strict verification and debugging before it can be installed. That's why nowadays unmanned aerial vehicles are widely spread. As a mirror of aviation, unmanned aerial vehicles has two most widely spread models. The first one is helicopters, like drones and different multi-rotor system, and the second one is planes, which are used for long distance flying to solve the task of monitoring and so on. If unmanned aerial vehicles want to increase the sphere of application, it should increase its functionality without increasing the power consumption during the flight. Because little aviation nowadays is strictly bordered with existing power plants. It can be reached by applying no new aerodynamical scheme, by applying new strategies for control the drones and different UAVs. We suggest that we could increase the functionality of the quadrocopter by embedding the tilt rotor scheme inside it. This way we are going to change aerodynamical scheme in the air, so we could change the airflow along the body during the flight. We can increase the flight reliability of the quadrocopter by increasing the number of degrees of freedom of the drone, and it can give us the flexibility of control strategies, so we can move our drone by different strategies in one direction. To describe our model mathematically, we have done several assumptions. First, we think that our drone is a symmetrical body, and also we are going to neglect position holding function. This means that we will have an external controller, like an operator or someone else, who will control the yaw and throttle of our drone. And we will borrow different solutions and components which are actually used in drones to give us possibility to realize our drone in practice. In this slide you can see the scheme of our quadcopter. We have 4 independent motors. Each motor have 3 degrees of freedom. We can control the tilt in this motor along the alpha and beta angles, and we can change the thrust of each motor. It's clear that the condition in which drone will stay in the one position or move with constant velocity is that the sum of the moment and sum of the forces should be 0. As idea for simulations control system, we see to divide the task of controller into the 2 parallel threads. The first thread will solve the task of horizontal alignment of our drone. We are going to reach it by changing the thrust of each motor, so this way we will control our drone along the pitch, roll and yaw axis. And this way we are going to stay it in a flat position. And the next task will be position holding function. We should coordinate our servo actuators to tilt our motor in different directions and to allow our drone to move in a horizontal plane, so at forward, back, left and right. On this slide you will see our idea for control system. It's necessary to realize controlling our drone along the horizontal plane, so we should calculate the forces of each motor, and also as we have to tilt them during the flight, we should compensate the angle that we have tilt our motor to keep it in to keep total thrust at the same level. As a position holding function, we add speed regulators to smooth the movements of our drone in the plane and to simplify the task of operator. To control our drone in horizontal position, we also use speed regulators and take as errors the angles of our frame. To evaluate our simulation, we have conducted several experiments. The first graph which you see is the flight is the result of the experiment in which we have made the adding of external moments to the frame of our drone and see the reaction of it. It seemed that our drone keep horizontal position, and after 2 or 3 seconds, it after applying an external moment, it come back to a flat position. And the second graph, you can see the application of external force in one direction. So in randomly in different time periods, we apply random number of forces and see the reaction of our system. It seemed that our system reacts correctly, and we decided to prove the correctness of our control system by creating a practical moment, by creating a practical implementation. So we decided to build a flying prototype of quadcopter with thrust vectors of each motor. And on the first photo you see the body of our drone, and the second photo shows you the electronics which you used in our drone. Now I want to show you a video of flying tests of our drone. On this video, we won't prove you that our drone really fly. Now you see how the motor tilts, and after made flight tests, we saw that our system reacts correctly to the control signal. It keep horizontal position, and we decided to conduct several experiments to compare our simulated model and build one. So we has recorded the acceleration acting along the different axes during the flight, and compare them with obtained in simulation. And now you can see the obtained results. We put it on the same graphs. On this graph, the yellow lines shows the simulated acceleration, and the orange lines shows the experimental acceleration. They are very close to each other, and the trends are absolutely the same. This way, I could say that obtained results look like accurate, and our control system allows us allows our drone to fly. And according of what I said, I could made several conclusions. We have made the mathematical model of our drone, and also we has suggest a control system and prove its correctness by simulation and the practical research. We have compared the practical and simulated results, and they are very close. So I could say that the obtained the research which we have conducted is very good, and our drone has different advantages in comparison with ordinary quadcopter. I would say that the main, for my opinion, one is that we reduce the drag during the flight, and this way we can increase the flight range of our drone, and also we can increase the stability in a strong side wind during the flight. Also, our model has very interesting feature like a horizontal position of the frame during flight. It can be used for unusual delivery tasks, and it can also be used maybe for a film recording, because we can move the camera in flat plane. According to our future plans, we are going to adapt our controller to autopilot, and also the main task why we are working on this project is that we are going to create a solution for a control UAV which try to realize the heliplane scheme, and they have a tilt rotor, but nowadays they don't use them during the flight control. and this way they lose the advantage of tilt rotor scheme. During the flight they use tilt rotor only during the transfer from a helicopter to plane and vice versa, and our algorithm should give them realize such advantage. On the next slide you could meet our team, and that's all. Thank you for your attention.